Hello and welcome to the video. In this video I'm going to be solving 4 more questions from exercise 1b of RS Agarwal real numbers. In the last video I had solved 4 questions and gave you an explanation of Euclid's division lemma. If in case you have not watched that video, I would suggest that you watch that video first and then continue with this video. The aim for this video is to do questions 19, 20, 21 and 24. I've already completed these questions and I'm going to be focusing on 19, 20, 21 and 24. Later on in the last video, I may focus on the remaining 3 questions and a few more questions added. So for this video, I want you to revise of whatever I've done in the previous video and then proceed further. Alright, so we talked about Euclid's division lemma in the last video and how to find a LCM and HCF and all the questions which is dependent on A is equal to bq plus r. So let's look at the first 19th question, not the first question, the 19th one. Find the smallest number which when increased by 17 is exactly divisible by both 468 and 520. So when I say that any number is completely divisible by another number, what does it mean? Let's say for example, I am taking a number, let's say 2. Okay. And I know that 48 is an even number and 48 is divisible by 2 completely, which simply means that the remainder is going to be a 0. So that also means that 48 can be written as 24 into 2. Or if I'm looking at this in the terms of bq plus r, then the remainder is going to be 0, which means A is simply going to be bq. That's what it means. So he wants me to find the smallest number, some number. So here is what I'm going to do. I'm going to say, let the number be A. I'm taking some number A. Now this number has to be increased by 17. If that is done, then it's divisible by 468 and also by 520. 468 and also by 520, which means therefore is divisible by 468 and 520, which means that I can write A plus 17 as 468 into some quotient Q1, and also A plus 17 can be written as 520 into some quotient Q2, right? So let's for now consider this number to be some m. I'm going to take out this and write m over here. So m is a number which is divisible by both these numbers, which basically means that m has to be the LCM of these two. If you recollect again, I have told you LCM of A and B, if it is m, then A divides m and B divides m completely. When I talk about the HCF of A and B as equal to, let's say, n, then n divides A and n divides B completely, right? So let me then find out what is the LCM of 468 and 520. How do I do that? Well, we go with prime factorization. That's what it is. So 468 is going to be equal to 2 square into 3 square into 13. Let me write this as A plus 17 again. I'm also going to be factorizing 520. So 520 is going to be equal to 2 cube into 5 into 13. So what is the LCM of 468 and 520, right? The LCM of 468 and 520 is all the factors. Here I'm going to pick up 2, 3, 15 and also 5. When I multiply, I get 4680. 4680. So 4680 is that particular number which is completely divisible by 468 and 520. And therefore, I can now say that a plus 17 is 4680, which means the value for a is 4680 minus 17, and that's going to give me how much? The value for a as equal to 4663. I hope you have understood this very simple process. Again, a is equal to bq plus r, and that should be good enough. Let's look at the 20th question now. 20th question is a bit interesting because it involves two concepts. Okay, I'll come back to this concept a bit later. Let me first focus on this. Now, if I ask you, give me the greatest two-digit number. Let's say I'm asking you for the greatest two-digit number which is divisible by 4. I'm simply saying the greatest two-digit number, which is 99, let's say. Obviously, 99 is not divisible by 4. I will try dividing 99 by 4. I get 4 2s are 8, 1, 19, 4 4s are 16. The remainder is a 3. So I can write 99 as equal to 4 into 24 plus 3. 4 into 24 plus 3. A is equal to bq plus r. But if I transpose 3 to the left hand side, then I'm going to remain with 96 is equal to 4 into 24. And that tells me that 96 is completely divisible by 4. And that's my greatest two-digit number, which is completely divisible by 4. What if I ask you for the greatest three-digit number, which is divisible by 4? Well, you go for 999. You repeat the same process. A is equal to bq plus r, and then you subtract the remainder. You should get the number. So that's what we're going to do with the greatest four-digit number here. But what is that number that we're going to divide by is decided by this concept, which is I'm looking for a number which is divisible by 15, 24 and 36. Now, what is that number? Is it lesser than 15, 24 and 36 or a greater number? Obviously, it's a greater number. In this case, it's going to be the LCM. So let me first find out the LCM. So I'm going to write 15 as 3 into 5 and 24 as, I know 24 is 8 into 3, 8 is 2 cube. So this is 2 cube into 3, and 36 is nothing but 6 square, and 6 can be written as 2 into 3. So that's 2 square into 3 square. 9 4s are 36. That's also fine. So what's going to be the LCM of 15, 24 and 36? The LCM of 15, 24 and 36 is 2 into 3 into 5. The highest power of 2 is a 3. The highest power of 3 is a 2. So how much is this now? 8 5s are 40, 40, 360. Okay. Now, 360 is completely divisible by 15, 24 and 36. And all the multiples of 360 is completely divisible by 15, 24 and 36. Which is 720 and then the next number, and it just goes on like that. So I now need to find out the greatest four-digit number, right? So what am I going to do? I'm going to take the greatest four-digit number. 9,999 is the greatest four-digit number. Let's divide this. 2 remains, 279. So 9,999 can be written as 360 into 27 plus 279. You transpose 279 to the left hand side, so you'll have 9,999 minus 279 as equal to 360 into 27. So how much is this now? 9,999 minus 279. And that's going to give you 9,720. Therefore, the required number is 9,720. That is it. Therefore, 9,720 is the greatest 4-digit number divisible by 15, 24 and 36. All right, wonderful. Let's move on. Let's look at the next question. So the question says, find the largest 4-digit number which when divided by so and so leaves a remainder of 3 in each case. It is similar to the previous question with a little bit of change. Okay, I am looking for the largest 4-digit number. Obviously 9,999 is the largest 4-digit number, and then I'm going to divide it by the LCM of these numbers. When I do that, I will get the multiples of the LCM of 4, 7 and 13. Let's do this. 4 is going to be 2 square. 7 is just 7 itself. 13 is already a prime number, so it's simply a 13. So the LCM of 4, 7 and 13 is going to be equal to 2 square into 7 into 13. So I can write 9,999 as equal to 364 into 27 plus 171. And when I transpose 171 to the left hand side, what I end up getting is that. So let me quickly subtract this. How much is this going to be? 9,828. This basically means that when I'm dividing 9,828 by 364, I'm going to get the remainder as 0. But if I need a remainder of 3, I'm going to be adding a 3 on both the sides. Now, if you can look at this, I'm writing this as A is equal to bq plus r. So the number is 9,831, which is equal to 364 into 27 plus 3. And here is the remainder 3. Therefore, the required number is is 9,831. Pretty simple. Let's look at the next one. The next question is another interesting question, actually speaking. I looked for a solution on this one. Even RS Agarwal does give us a little bit of explanation on this. But it doesn't give in terms of A is equal to bq plus r. Okay, I'm going to try and explain this to you with the help of Euclid's division lemma itself. Okay, so let's see. Find the least number which when divided by this, and this. Let's not go further. I'm just looking for a number which is divisible by all of these. Now, what is that number which is divisible by 20, 25, 35 and 40? LCM. Let's find out the LCM first. So, 20 is 4 into 5, so that's 2 square into 5. 25 I know is a 5 square. 35 is 5 into 7. 40 is 8 5s are 40, so that's a 2 cube into 5. All right. So what's the LCM of these? So the LCM of 20, 25, 35 and 40 is equal to, I'm going to take all the factors, so 2 into 5 into 7. So the highest powers is 3, 2 and then a 1. 1400. So that's going to be the LCM of all of these numbers. Okay. Great. So I'm supposed to be finding that number, which is divided, when divided by so and so, leaves a remainder of 14, 19, 29 and 36. Let me start by saying, let the number be sum A. I don't know what that number is, it's sum A. Therefore, A when divided by 20 and with the quotient of Q1 gives me a remainder of 14. A when divided by 25 with the quotient, let's say Q2, gives me a remainder of 19. And A when divided by 35 with the quotient of Q3 gives me a remainder of 29. And A when divided by 40 gives me a remainder of 34. Now this is the scenario, all right? So remember this, please. I'm going to make a small change to all these equations. What's the change I'm going to make? I'm going to write this as 20 Q1 plus 20 minus 6. I'll do the same thing here. 25 Q2 plus 25 minus 6. Here again I have 35 Q2 plus 35 minus 6, and then a 40 Q4 is a Q3, sorry, plus 40 minus 6. All right. Now, can I further A as equal to, if I consider this 20 taken common out from these two terms, I'll remain with the Q1 plus 1 minus 6. Again, A will be equal to 25 taken common out from here. I'll remain with the Q2 plus 1 minus 6. And then I'll have A 35 taken common out from these two terms. I'll have Q3 plus 1 minus 6. Again, I'll have A as equal to 40 taken common out. Q4 plus 1 minus 6. So look at this, guys. What is this now? All these equations can now be written as A is equal to 20 sum Q5 minus 6. A is equal to 20 sum Q6 minus 6. I'm taking Q5 as, Q1 plus 1. Another number. Again, I have A is equal to 35 Q7 minus 6, and then A is equal to 40 Q8 minus 6. Further, all these equations can now be written as A plus 6 is equal to 20 Q5. A plus 6 is equal to 25, 5 Q6. A plus 6 is equal to 35 Q7. A plus 6 is equal to 40 Q8. So what is this telling me? It tells me if I can take A plus 6 as equal to some M. M is divisible by 20, 25, 35 and 40, which basically means M is the LCM. Therefore, A plus 6 is equal to the LCM, which I've already found out as 1400. Okay, 1400. So what does that mean? It simply means that A is equal to 1400 minus 6, which is 1394. All right. 1394. I hope you understood this. It's a bit of a lengthy explanation, but it completely makes sense, right? In this video, we have spoken about 3 questions: 20, 21, 24, right? Very simple ones. Again, usage of the concept of A is equal to BQ plus R. Find the greatest 4-digit number of 4 digits which is exactly divisible by so and so. So if I'm looking for a number which is divisible by some numbers, then it's basically the LCM. I take the greatest 4-digit number and then I divide it. Then write A is equal to BQ plus R, and then you get the number as 9720. Same thing again, almost a similar question. We find the LCM, which is 364. Repeat the process, and then you get the number as 9831. Remember how I'm going about with it. A is equal to BQ plus R. Another interesting question, very interesting question actually. LCM, I'm taking the number as A, which means remainder is 14 in the first case, 19 in the second case, 29 in the next, and then 34 in the last. Made a small change to it, wrote 14 as 20 minus 6, 19 as 25 minus 6, 35 minus 6, and 40 minus 6. So when I take a common out, I'll remain with these, which are by itself some numbers, which I wrote it as Q1, Q3, and so on. So now what happens after I transpose 6 to the left hand side? I get that, which means A plus 6 has to be the LCM. And what's the LCM? 1400. And that gives me the value for A as 1398. Alright. That's it for this video. I hope you have understood whatever I explained and also watched the previous video. If you want me to do any more questions from the LCM SCF word problems of real numbers, please let me know. Type the question in the chat window, or you can also paste a picture of the video. I'll pick that up and try and solve that for you. Thank you very much for your patience. Thank you for joining. Goodbye.